When NASA's computers started receiving impossible data from the edge of our solar system, scientists couldn't believe what they were seeing. After 47 years of silent travel through the cosmic void, Voyager 1 has transmitted discoveries that challenge everything we thought we knew about interstellar space. Today, on Sci and Why, we're unveiling the shocking revelations that have left astronomers questioning the very nature of our universe. From mysterious humming sounds to unexplained cosmic phenomena, these findings will change how we view our place in the galaxy forever. The impossible mission that defied all odds. Voyager 1 was designed to last just 5 years, yet it's still transmitting data after nearly half a century, making it humanity's most successful space mission ever. In 1977, NASA launched what seemed like a routine planetary exploration mission. Voyager 1 and its twin, Voyager 2, were built using 1970s technology with computer systems containing just 70 kilobytes of memory, less than a single smartphone photo today. Originally designed to study Jupiter and Saturn during a rare planetary alignment, these spacecraft were expected to go silent by 1982. Instead, they embarked on humanity's greatest journey into the unknown. The mission capitalized on a once-in-176-year gravitational alignment that allowed the spacecraft to use planetary gravity as cosmic slingshots, accelerating them toward the outer solar system. What began as a 5-year mission has become a 47-year odyssey that redefined our understanding of space. Today, Voyager 1 travels at 38,000 miles per hour through interstellar space, sending back data from regions no human-made object has ever explored. The fact that this 1970s technology continues functioning in the harsh environment of deep space represents one of engineering's greatest triumphs. Crossing the final frontier into interstellar space. On August 25, 2012, Voyager 1 became the first human-made object to leave our solar system, entering a realm where the sun's influence ends and true interstellar space begins. The moment Voyager 1 crossed the heliopause, the boundary between our solar system and interstellar space, marked a historic milestone for humanity. At 11 billion miles from the sun, the spacecraft detected a dramatic change in its environment. The solar wind, a stream of charged particles flowing from our star, suddenly dropped to nearly zero, while cosmic radiation increased threefold. This transition wasn't gradual, it was like stepping from a protected harbor into an open ocean. The heliopause acts as our solar system's shield, protecting us from the galaxy's intense radiation. Beyond this boundary lies the interstellar medium, a vast expanse filled with remnants from ancient star explosions, cosmic dust, and mysterious phenomena that scientists are only beginning to understand. Voyager 1's instruments detected strange magnetic field fluctuations and unexpected particle densities that contradicted existing models. The spacecraft found itself in an environment where the familiar rules of our solar system no longer applied. This crossing represented more than a technical achievement. It was humanity's first step into the galactic neighborhood, opening a new chapter in space exploration. The mysterious humming sound from the void. Voyager 1 detected a low, persistent humming sound in the supposed silence of interstellar space, a discovery that has scientists completely baffled about what's creating this cosmic symphony. In the vacuum of space, sound shouldn't exist. Yet Voyager 1's instruments detected something extraordinary, a continuous, low-frequency humming emanating from the interstellar medium itself. This wasn't sound as we understand it on Earth, but rather vibrations in the sparse gas and plasma that fills the space between stars. The humming appears to be generated by the interstellar medium's interaction with cosmic phenomena, creating a kind of cosmic background music that permeates our galaxy. Scientists describe it as similar to the sound of wind through trees, but occurring in a medium millions of times thinner than Earth's atmosphere. The discovery challenges our understanding of how energy propagates through space, and suggests that interstellar space is far more active than previously thought. These vibrations might be caused by stellar winds from distant stars, shockwaves from supernovae, or even more exotic phenomena we haven't yet identified. The humming varies in intensity and frequency, suggesting it responds to changes in the local interstellar environment. This cosmic soundtrack provides scientists with a new way to study the structure and dynamics of our galaxy, turning Voyager 1 into an interstellar seismograph. The heliopause's shocking behavior. You know, the boundary of our solar system isn't the stable barrier scientists expected. Instead, it's moving, shifting, and behaving in ways that completely contradict our models of how space works. The heliopause, which is our solar system's protective boundary, has revealed itself to be way more dynamic and unpredictable than anyone imagined. Rather than maintaining a steady position, this cosmic border actually fluctuates dramatically, sometimes moving billions of miles in relatively short periods. Data from Voyager 1 and 2 shows the heliopause exhibiting strange angles and irregular shapes that just defy current theoretical models. Back in 2014, NASA's Interstellar Boundary Explorer satellite detected unusual brightening of energetic particles, which suggested massive disturbances in the boundary region. These irregularities simply don't match existing predictions about how the solar wind should interact with interstellar space. The heliopause's movement might even explain why Voyager 1 and 2 reached interstellar space 6 years apart, even though they followed similar trajectories. Scientists have observed the boundary creating shock waves and turbulence that ripple through both the solar system and interstellar space. This dynamic behavior suggests our solar system is more like a living organism than a static structure, constantly responding to galactic forces we're only beginning to understand. The implications are pretty profound. If our solar system's boundary is this unstable, what does that mean for the protection it provides against cosmic radiation?
Electronic confusion in the cosmic deep.
So, in May 2023, Voyager 1 began transmitting garbled, incoherent data instead of scientific measurements, as if the spacecraft was suffering from electronic dementia in the depths of space. 46 years into its mission, Voyager 1 experienced what NASA engineers described as electronic aphasia. The spacecraft's attitude articulation and control system started sending random, meaningless data instead of coherent status reports. From Earth's perspective, it honestly looked like Voyager 1 was losing its ability to communicate effectively, much like how a person with aphasia struggles to form coherent sentences. The mystery deepened when engineers realized that, despite the garbled communications, Voyager 1's radio signal remained strong and stable, which meant the spacecraft was still functioning normally. Its scientific instruments just kept operating without any awareness of the communication problem, and the fault protection system, designed to put the spacecraft in safe mode during emergencies, never activated. After a lot of investigation, NASA discovered the problem. The control system had switched to a computer that had been dormant for years, basically trying to use obsolete hardware to process modern commands. The solution required sending precise instructions across 15 billion miles of space to reactivate the correct computer system. This incident really highlighted the incredible challenge of maintaining 1970s technology in the harsh environment of interstellar space, where cosmic radiation constantly bombards the spacecraft's electronic systems. Surviving the impossible, technology beyond its limits. Voyager 1's instruments should have frozen solid years ago when NASA turned off their heaters to save power, yet they continue functioning perfectly in temperatures that would destroy any other spacecraft. Honestly, the laws of physics suggest Voyager 1 should have died long ago. As the spacecraft's plutonium power source gradually decays, NASA has had to shut down non-essential systems to conserve energy. In 2019, engineers made the tough decision to turn off the heaters that keep the scientific instruments warm in the -270°F environment of space. This should have been a death sentence for the delicate electronics, yet all 5 instruments continue operating flawlessly. NASA engineers are genuinely puzzled by this phenomenon, unable to explain how 1970s technology survives in conditions that would instantly destroy modern spacecraft. The instruments operate in temperatures hundreds of degrees below their design specifications, totally defying every engineering principle. Some scientists theorize that the instruments generate just enough internal heat from their electronic operations to prevent complete freezing, while others suggest that decades of cosmic radiation exposure may have altered the materials in unexpected ways. The spacecraft's resilience has actually forced engineers to reconsider fundamental assumptions about electronics in extreme environments. This unexpected durability has extended Voyager 1's mission far beyond anyone's wildest expectations, allowing it to keep transmitting data from the interstellar frontier where no human technology has ever ventured.
The cosmic radiation bombardment.
Beyond our solar system's protective shield, Voyager 1 faces a constant barrage of cosmic radiation that's, wow, 3 times more intense than anything experienced within our cosmic neighborhood. Interstellar space has revealed itself to be a far more hostile environment than scientists ever anticipated. Once Voyager 1 crossed the heliopause, it encountered cosmic radiation levels 3 times higher than those within our solar system's protective bubble. This intense radiation, consists of high-energy particles accelerated by distant supernova, black holes, and other extreme cosmic phenomena. These particles constantly bombard the spacecraft, gradually degrading its electronic systems and creating cumulative damage that just builds over time. The radiation can actually flip individual bits in computer memory, causing small errors that accumulate into much larger problems. It's honestly like trying to maintain a complex machine while it's being continuously sandblasted by invisible particles traveling at nearly the speed of light. Despite this constant assault, Voyager 1 systems continue functioning through a combination of robust 1970s engineering and clever software workarounds developed by NASA's engineers. The spacecraft's experience provides crucial data about the radiation environment that future interstellar missions will face. Understanding these conditions is essential for designing spacecraft capable of surviving the journey to nearby star systems. Voyager 1 has become humanity's first radiation scout, mapping the dangerous terrain that lies between the stars and providing invaluable information for future deep space exploration.
Software updates across the cosmic void.
NASA engineers regularly send software updates to Voyager 1 across 15 billion miles of space, basically providing tech support to a computer system that's actually older than most of the engineers working on it. Maintaining Voyager 1 requires honestly some of the most challenging technical support in human history. The spacecraft operates with 1970s computer systems programmed in assembly language, a low-level programming code that directly controls hardware components. When problems pop up, NASA engineers have to write new software instructions and transmit them across the vast emptiness of space, where radio signals take over 22 hours just to reach the spacecraft. The engineers use a mix of assembly language and pseudocode to create efficient programs that won't overwhelm the spacecraft's limited 70-kilobyte memory. Each software update has to be perfect. There's really no chance for quick fixes or patches when your target computer is billions of miles away. These updates have solved critical problems throughout the mission, from reactivating backup systems to working around failing components. In one case, a software update saved Voyager 1 from potential disaster by activating fail-safe mechanisms when a hardware component failed. The process requires engineers to think like programmers from the 1970s, using techniques and limitations that modern computer scientists rarely ever encounter. This cosmic tech support is, honestly, one of the most impressive examples of long-distance troubleshooting ever attempted, keeping humanity's most distant ambassador operational out in the depths of interstellar space.
Revolutionary discoveries that changed everything.
Voyager 1's journey revealed that Jupiter has 3 delicate rings. Saturn's rings contain thousands of intricate braids, and volcanoes exist on moons we once thought were totally dead, completely revolutionizing our understanding of the outer solar system. Before Voyager 1's grand tour, our knowledge of the outer planets was limited to fuzzy telescope images and just basic orbital mechanics. The spacecraft's close encounters showed us a solar system far more complex and dynamic than anyone had imagined. Jupiter, which we thought was a calm gas giant, turned out to be a world of extremes, with hundreds of violent storms, glowing auroras, and 3 previously unknown rings that are honestly more intricate than fine jewelry. Saturn's rings, once considered simple and few in number, revealed themselves as thousands of individual ringlets with braided structures that seemed to defy the laws of physics. Most shocking of all was the discovery of active volcanoes on Jupiter's moon Io and nitrogen geysers on Neptune's moon Triton, erupting at temperatures just 40 degrees above absolute zero. These findings totally shattered the idea that volcanic activity was unique to Earth and the inner planets. Maybe most significantly, Voyager 1 identified potential habitats for life on Europa and Enceladus, moons harboring vast liquid oceans beneath their icy surfaces. These discoveries transformed our understanding of where life might exist in the universe, expanding the concept of habitable zones way beyond traditional planetary boundaries. The mission's revelations keep influencing space exploration today, inspiring missions to study these potentially life-bearing worlds in much greater detail.
The eternal journey into galactic immortality.
In 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445, carrying humanity's golden record message to any intelligent civilization that might find it. Voyager 1's scientific mission may end in the late 2020s when its power finally fails. But honestly, its journey through the galaxy is just beginning. The spacecraft will keep traveling through interstellar space for millions of years, eventually becoming an artifact of human civilization drifting among the stars. In about 300 years, it'll enter the Oort cloud, a spherical shell of comets surrounding our solar system. After 30,000 more years, it'll completely escape the sun's gravitational influence and start orbiting the center of the Milky Way galaxy alongside billions of stars. The golden record attached to Voyager 1 contains sounds, images, and greetings from Earth in 55 languages, serving as a cosmic message in a bottle for any intelligent beings who might encounter it. This record includes everything from Bach's music to whale songs, from mathematical formulas to images of human faces. The spacecraft has become humanity's first interstellar ambassador, carrying our story into the cosmic deep. Long after human civilization has evolved beyond recognition, Voyager 1 will continue its silent journey through the galaxy, a testament to human curiosity and our drive to explore the unknown. The mission represents more than scientific achievement. It really embodies humanity's eternal quest to understand our place in the universe and reach beyond the boundaries of our cosmic home. From mysterious cosmic humming to impossible electronic survival, Voyager 1's 47-year journey has shown that our universe is far stranger and more dynamic than we ever imagined. This brave little spacecraft keeps rewriting the textbooks of space science while carrying humanity's message to the stars. If you're fascinated by these incredible cosmic discoveries and want to explore more mind-bending space mysteries, go ahead and hit that like button, share your thoughts about Voyager's amazing journey in the comments, and subscribe to Sci and Y for more adventures into the unknown. Thanks for watching. Keep exploring the cosmos. Back in 2017, humanity encountered our first confirmed interstellar visitor, a mysterious object called Oumuamua. Scientists at first thought they had a pretty good idea of what it was, but then came 2I/Borisov in 2019, and after that 3I/Atlas in 2025. Each new discovery has made Oumuamua look more and more bizarre, and honestly, even potentially artificial. As we study more of these interstellar objects, the strange properties of our first visitor really stand out like a cosmic anomaly. So today we're diving into how recent discoveries are making Oumuamua seem less like a natural space rock, and more like, well, something entirely different.
The discovery of 3I Atlas.
The astronomical world was really shaken up when the Asteroid Terrestrial Impact Last Alert System, or ATLAS, detected humanity's third confirmed interstellar visitor in January 2025. Unlike its predecessors, 3I/Atlas showed immediately recognizable comet-like behavior, with a distinct tail and visible outgassing as it got closer to the sun. The object, measuring about 800 meters across, followed a classic hyperbolic trajectory, which made its extrasolar origin totally clear. There was just no doubt about it. What made this discovery especially significant was how normal it appeared compared to the enigmatic Oumuamua that had baffled scientists for years. 3I/Atlas behaved exactly as astronomers would expect an interstellar comet to behave. It brightened in a predictable way as solar heating vaporized surface ices, creating the classic coma and tail that define cometary objects. The discovery team, led by astronomers at the University of Hawaii, immediately jumped into comparative studies with previous interstellar visitors. As data started pouring in from observatories all over the world, one thing really stood out. 3I/Atlas was acting like a completely normal natural comet, which just made Oumuamua's bizarre properties seem even more anomalous and, yeah, potentially artificial. This stark contrast forced scientists to reconsider everything they thought they knew about our first interstellar guest. The Oumuamua discovery. On October 19, 2017, the Pan-STARRS-1 telescope in Hawaii detected a faint moving object that would, honestly, revolutionize our understanding of interstellar visitors. Initially designated 2017 U1, the object was quickly reclassified as the first confirmed interstellar asteroid and given the Hawaiian name Oumuamua, which means scout or messenger from afar. The discovery team, led by Dr. Robert Warwick at the University of Hawaii, realized they were seeing something truly unprecedented, an object with a hyperbolic orbit, showing it had come from outside our solar system. Within just days of detection, observatories worldwide turned their instruments toward this cosmic visitor, racing against time as it rapidly moved away from the sun. The object's discovery challenged existing classification systems, actually forcing the International Astronomical Union to create a whole new designation category for interstellar objects. Oumuamua's trajectory indicated it had been traveling through interstellar space for millions of years before its chance encounter with our solar system. The excitement was just palpable in the astronomical community. Humanity had finally found definitive proof that objects regularly travel between star systems, opening up a new window into the broader galactic environment and the materials that exist in the vast spaces between stars. Oumuamua's strange properties. Oumuamua immediately stood out as unlike any object previously observed in our solar system, displaying properties that really defied our conventional understanding of asteroids and comets. The object's light curve variations suggested an extremely elongated shape, possibly 10 times longer than it was wide, kind of like a cosmic cigar or needle, instead of the usual rounded shapes we see with asteroids. Its unusual geometry meant Oumuamua tumbled through space every 7.3 hours, causing dramatic brightness changes as different surfaces reflected sunlight toward Earth. Even more puzzling was its extraordinary speed. The object was traveling at 26 kilometers per second relative to the Sun, much faster than typical solar system objects. Spectroscopic observations showed a reddish surface similar to some asteroids, but Oumuamua had no signs of water vapor, dust, or gas emissions that we usually see with comets when they're heated by the sun. This absence of outgassing was especially strange since most objects from the outer reaches of space contain volatile materials that should vaporize when they get close to our star. The combination of unusual shape, high speed, lack of cometary activity, and mysterious surface composition made Oumuamua a real cosmic puzzle, challenging some of our most fundamental assumptions about interstellar objects and what we expect them to be like. The acceleration mystery. The most perplexing aspect of Oumuamua really emerged when astronomers analyzing its trajectory discovered that the object was accelerating away from the sun in a way that just didn't match what we'd expect from gravitational forces alone. This unexpected acceleration, first reported by Dr. Marco Micheli from the European Space Agency, suggested that some force was actively pushing Oumuamua beyond the influence of solar gravity. Now, typically, comets show similar acceleration because of outgassing. When solar heating vaporizes surface materials, the expelled gas creates this kind of rocket-like thrust. But Oumuamua, well, it showed no visible signs of outgassing, no detectable coma, and absolutely no dust trail that could explain this mysterious acceleration. The acceleration itself was small but definitely measurable, about 2.5 times 10 to the -6 meters per second squared, which over time was enough to significantly alter the object's trajectory. This phenomenon kind of violated everything scientists understood about how inert space rocks should behave when only gravity is at play. The absence of observable outgassing while still experiencing this unexplained acceleration ended up creating a scientific paradox that, honestly, sparked some pretty intense debate within the astronomical community. Some researchers proposed exotic explanations like sublimating hydrogen ice or other invisible processes, while others started to consider more radical possibilities, including the controversial suggestion that Oumuamua might actually represent humanity's first encounter with artificial technology from another civilization. Scientific investigations. So, following Oumuamua's mysterious behavior, scientists all over the world launched comprehensive observational campaigns using the most powerful telescopes we have to try to understand this enigmatic visitor. The Spitzer Space Telescope, for example, conducted crucial infrared observations that provided insights into the object's thermal properties and surface composition. These observations revealed that Oumuamua had an unusually reflective surface with an albedo of about 0.1, which is similar to carbon-rich asteroids but, inconsistent with what we see in typical icy comets. The object's thermal signature also indicated it wasn't actively shedding material, confirming the absence of traditional cometary outgassing, even though it was so close to the sun. Radio telescope arrays, including the Green Bank telescope, carried out search for extraterrestrial intelligence protocols to see if there were any artificial signals coming from the object, but none were found. Meanwhile, ground-based observatories worldwide coordinated their observations to precisely track Oumuamua's trajectory and rotation, building detailed models of its shape and behavior. These collaborative efforts showed that the object's acceleration just couldn't be chalked up to measurement errors or any previously unknown gravitational influences. All this data painted a picture of an object that was, frankly, unlike anything in our solar system's inventory, exhibiting properties that really challenged our conventional understanding of natural space debris and raised some pretty profound questions about its true nature and origin. The alien hypothesis. Harvard astrophysicist Dr. Avi Loeb, he really shocked the scientific community by proposing that Oumuamua might actually be humanity's first encounter with artificial extraterrestrial technology. In his controversial analysis, Loeb suggested that the object could be an artificial light sail, a thin, reflective sheet designed to catch solar radiation for propulsion, kind of like concepts that human engineers have developed for interstellar travel. This hypothesis would elegantly explain Oumuamua's unusual acceleration without any visible outgassing, since radiation pressure from sunlight could provide the observed thrust on a surface that's sufficiently thin and reflective. Loeb calculated that a light sail only millimeters thick but hundreds of meters wide could, in fact, exhibit exactly the acceleration patterns observed in Oumuamua's trajectory. His proposal, which he published in the astrophysical journal Letters, argued that dismissing the artificial origin hypothesis without proper consideration was, honestly, just unscientific bias against extraordinary possibilities. The light sail theory generated intense controversy within the astronomical community, with many of Loeb's colleagues criticizing him for promoting what they considered sensationalist speculation without enough evidence. However, Loeb defended his analysis by pointing out that extraordinary claims require extraordinary investigation, and that ruling out artificial origins just because of our preconceptions about extraterrestrial technology would be scientifically irresponsible. His hypothesis sparked global media attention and, really renewed public interest in the search for extraterrestrial intelligence. The dark comet theory. In response to Loeb's alien hypothesis, astronomers Dr. Darrell Seligman from the University of Chicago and Dr. Gregory Laughlin developed an alternative explanation they termed the dark comet theory. Their model proposed that Oumuamua was composed primarily of hydrogen ice, frozen molecular hydrogen that would be, nearly invisible when sublimating in space. Unlike water ice, which creates visible clouds and tails when heated, hydrogen gas would be virtually undetectable using conventional observational techniques. This invisible outgassing could explain Oumuamua's mysterious acceleration without contradicting the absence of visible cometary activity. The researchers calculated that an object made largely of hydrogen ice would exhibit exactly the thermal and dynamical properties observed in Oumuamua, including its unusual reflectivity and acceleration pattern. Their theory suggested that hydrogen icebergs might be common in interstellar space, formed in the extremely cold conditions between stars where molecular hydrogen can freeze into solid form. This natural explanation provided a way to understand Oumuamua's anomalous behavior without invoking artificial origins or revolutionary physics. The dark comet model gained support from several prominent astronomers who preferred conventional explanations over extraterrestrial technology hypotheses. However, the theory also faced criticism regarding the stability of hydrogen ice under the thermal conditions Oumuamua experienced during its solar system passage. The ongoing debate. Despite the dark comet theory's scientific appeal, Dr. Avi Loeb remained skeptical of natural explanations for Oumuamua's behavior, continuing to advocate for serious consideration of artificial origins. Loeb criticized the hydrogen ice hypothesis on several grounds, arguing that such objects would be extremely fragile and unlikely to survive intact during interstellar travel spanning millions of years. He pointed out that hydrogen ice sublimates at very low temperatures, making it unlikely that sufficient material could remain frozen during Oumuamua's approach to the Sun to explain the observed acceleration. Additionally, Loeb noted that the dark comet theory required specific and somewhat contrived conditions to work, while the light sail hypothesis provided a more straightforward explanation for all observed anomalies. The scientific community remained deeply divided, with most astronomers favoring natural explanations while acknowledging the limitations of current models. The debate highlighted fundamental questions about scientific methodology. How much evidence is required to consider extraordinary hypotheses? and whether the search for conventional explanations sometimes prevents serious consideration of revolutionary possibilities. Leading journals published papers on both sides of the argument, with each camp identifying weaknesses in opposing theories. This ongoing controversy demonstrated how a single mysterious object could expose deep philosophical divisions within the scientific community about the nature of evidence, the burden of proof, and the appropriate response to phenomena that challenge established understanding.
Project Lyra mission concept.
The mystery surrounding Oumuamua inspired ambitious mission concepts designed to intercept and study the object directly before it disappeared forever into interstellar space. Project Lyra, proposed by researchers at the European Space Agency and Johns Hopkins Applied Physics Laboratory, outlined a technically feasible spacecraft mission that could potentially catch up with Oumuamua using advanced propulsion systems and gravity assist maneuvers. The mission concept involved launching a high-speed probe that would use multiple planetary gravity assists, including flybys of Earth and Jupiter, to achieve the tremendous velocity needed to intercept an object already traveling at interstellar speeds. Advanced ion propulsion systems would provide additional acceleration, potentially allowing the spacecraft to reach Oumuamua within 15 to 20 years of launch. The probe would carry sophisticated instruments including high-resolution cameras, spectrometers, and sample collection systems designed to definitively determine the object's composition, internal structure, and origin. Mission planners calculated that direct observation and analysis could resolve the debate between natural and artificial hypotheses once and for all. However, the enormous technical challenges and costs associated with such an ambitious interstellar chase mission made immediate implementation unlikely. The Project Lyra concept demonstrated both human ingenuity in mission design and the frustrating reality that our current technology limits our ability to investigate the most intriguing cosmic phenomena that briefly visit our solar system.
The Future Hunt.
The upcoming Vera C. Rubin Observatory, scheduled to begin operations in 2025, promises to revolutionize our ability to detect and study interstellar visitors like Oumuamua. This powerful survey telescope will scan the entire visible sky every few nights, potentially discovering dozens of interstellar objects annually, and providing the statistical sample needed to understand whether Oumuamua represents a typical example or a genuine anomaly. Early detection by Rubin Observatory would allow astronomers months or years to study new interstellar visitors, rather than the brief weeks available for Oumuamua analysis. The comparison between natural objects like 3I/Atlas and the enigmatic properties of Oumuamua will become increasingly important as more interstellar visitors are cataloged and characterized. If future discoveries consistently show normal cometary behavior while Oumuamua remains unique in its anomalous properties, the case for artificial origins would strengthen significantly. Conversely, finding additional objects with similar mysterious characteristics would suggest previously unknown natural processes operating in interstellar space. The resolution of Oumuamua's mystery may ultimately depend on discovering whether it represents an isolated cosmic oddity or the first member of a new class of interstellar objects. As our observational capabilities improve, and our sample of interstellar visitors grows, we may finally answer one of the most profound questions in modern astronomy. Did humanity's first confirmed interstellar guest represent our first encounter with alien technology? So there you have it. As we discover more normal interstellar objects like 3I/Atlas, Oumuamua's bizarre properties become increasingly difficult to explain through natural processes alone, whether it's an alien light sail, a hydrogen iceberg, or something entirely different remains one of astronomy's greatest mysteries. What do you think Oumuamua really was? Share your thoughts in the comments. If you enjoyed this cosmic mystery, like and share this video, and subscribe to Sci and Y for more incredible space discoveries. Until next time, keep looking up. Fresh observations of the mysterious interstellar visitor 3I Atlas are revealing properties that, well, challenge everything scientists thought they knew about this cosmic wanderer. What initially appeared to be a straightforward comet from another star system is now displaying characteristics that have some researchers questioning whether we're dealing with something far more extraordinary. The object's bizarre orbital path, suspicious timing, and anomalous behavior patterns are sparking intense debates in the astronomical community. Could this visitor be more than just another space rock drifting between the stars?
Fresh observations reveal mysteries.
The latest observational data from 3Y Atlas has sent shockwaves through the international astronomical community, revealing properties that really defy conventional understanding of interstellar objects. Advanced spectroscopic analysis conducted by Dr. Alan Fitzsimmons at Queen's University Belfast shows inconsistencies in the object's expected water-ice signatures, even though it looks comet-like as it approaches the Sun. Unlike typical comets that develop prominent tails and comas as solar heating sublimates their icy surfaces, 3I Atlas displays minimal outgassing activity that seems, honestly, artificially suppressed. The object's brightness variations follow patterns that suggest either an extremely unusual internal structure or maybe potentially artificial modifications to its surface properties. Dr. Michelle Bannister from the University of Canterbury notes that the thermal signatures just don't match any known class of natural celestial bodies, creating a scientific puzzle that's got researchers scrambling for explanations. Ground-based observations using the Keck Observatory have detected anomalous reflectivity patterns across different wavelengths, suggesting surface materials or structures that shouldn't exist on a primordial comet from interstellar space. These mysterious characteristics are forcing scientists to consider possibilities they previously dismissed as purely theoretical, opening up discussions about the true nature of our enigmatic cosmic visitor and whether it represents humanity's first encounter with something genuinely extraordinary. The scientific debate. The scientific community has become deeply divided over 3Y Atlas, with heated debates emerging between researchers who maintain it's a natural comet and those who suspect something far more extraordinary. Dr. Robert Warwick, who discovered the first interstellar visitor Oumuamua, argues that 3I Atlas exhibits typical cometary behavior, consistent with objects ejected from distant planetary systems during their formation phases. However, a growing faction of astronomers led by prominent researchers is challenging this conventional interpretation based on mounting observational anomalies. Dr. Matthew Knight from the University of Maryland emphasizes that while unusual properties don't automatically indicate artificial origins, they do warrant serious investigation rather than dismissal. The debate has become particularly intense regarding the object's thermal behavior, orbital characteristics, and structural properties that seem to contradict standard models of interstellar comet evolution. Traditional planetary scientists argue that exotic conditions in other star systems could naturally produce such anomalous objects, while skeptics point to the accumulating statistical improbabilities surrounding 3I Atlas's trajectory and timing. This scientific schism reflects broader tensions within astronomy about how to approach potentially paradigm-shifting discoveries without abandoning rigorous scientific methodology. The controversy has prompted unprecedented international collaboration as researchers desperately attempt to resolve fundamental questions about this cosmic visitor before it disappears forever into the depths of interstellar space. The artificial origin hypothesis. Harvard astrophysicist Dr. Avi Loeb has emerged as the most prominent advocate for considering artificial origins for 3E Atlas, drawing on his controversial analysis of Oumuamua to argue for serious investigation of extraterrestrial technology hypotheses. Loeb's Galileo project, established specifically to search for evidence of alien artifacts, has allocated significant resources to studying 3I Atlas, using advanced observational techniques and artificial intelligence analysis systems. His team argues that the object's unusual properties, including its suspicious orbital alignment, minimal outgassing despite solar proximity, and anomalous structural characteristics, collectively suggest possible artificial construction or modification. Loeb emphasizes that dismissing extraordinary possibilities without thorough investigation represents scientific prejudice rather than rigorous methodology, particularly given the unprecedented nature of interstellar visitors. His hypothesis proposes that 3Y Atlas could represent a reconnaissance probe or derelict spacecraft from an extraterrestrial civilization, deliberately designed to appear comet-like while conducting systematic observations of our solar system. Critics argue that Loeb's theories lack sufficient observational evidence and rely too heavily on speculation rather than proven scientific principles. However, his work has sparked crucial discussions about how the scientific community should respond to potentially revolutionary discoveries that challenge fundamental assumptions about our place in the universe. The debate continues to influence funding priorities and observational strategies for studying this and future interstellar visitors.
Unusual detection pattern.
The discovery timeline of 3I/Atlas reveals some deeply troubling patterns that, honestly, suggest the object may have been deliberately avoiding detection during its approach to our solar system. Even though it entered our solar system in early 2024, the object wasn't discovered until June of the following year, 2025. That means it spent over a year traveling through space without triggering any of our advanced detection networks. Dr. Catalina Oiza from the European Space Agency points out that, objects of this size should have been detected much earlier by automated survey systems like Atlas and Linear. This really raises questions about how it managed to remain hidden for so long. The object's approach vector from the galactic south actually placed it in a region of the sky that receives less intensive monitoring, which might explain the delayed detection but also suggests, perhaps, some knowledge of our observational blind spots. What's even more concerning is that there's evidence 3I/Atlas may have altered its trajectory slightly during its undetected approach, and this is based on retroactive analysis of archival telescope data that initially dismissed some faint signals as imaging artifacts. Dr. John Tonry, who leads the Atlas detection system at the University of Hawaii, admits that the object's discovery pattern represents a significant failure in current detection protocols. This delayed recognition has cost us precious observation time and honestly, raises some uncomfortable questions about whether other undetected visitors have passed through our solar system unnoticed, potentially conducting systematic surveillance of Earth and, human civilization.
Suspicious orbital characteristics.
Statistical analysis of 3I/Atlas's orbital trajectory reveals probability patterns so, improbable that they're forcing astronomers to question whether its path through our solar system could possibly be natural. The object's alignment with the ecliptic plane, the flat disk containing most planetary orbits, shows a deviation of less than 0.2 degrees, which is a precision that occurs in fewer than 0.2% of random interstellar trajectories according to orbital dynamics models. Even more remarkable are the calculated close encounters with multiple planets during its passage, including near-miss approaches to Venus, Mars, and Jupiter. Altogether, these encounters represent probability odds of about 0.005% for a natural occurrence. Dr. Davide Farnochia from NASA's Jet Propulsion Laboratory describes these orbital characteristics as, quote, statistically suspicious, and says they're worthy of detailed investigation rather than just casual dismissal. The trajectory analysis also shows that 3I/Atlas will achieve optimal positioning for observing Earth's electromagnetic signatures, like our radio communications and radar emissions during its closest approach phase. Now, some skeptical scientists argue that unusual orbital alignments do occasionally happen in nature and don't automatically indicate artificial guidance systems. But the cumulative probability of all these observed characteristics really challenges conventional explanations. Computer simulations run by planetary dynamicists show that achieving such precise orbital parameters would require either some extraordinary cosmic coincidences or maybe deliberate course corrections throughout the object's journey. These findings have sparked some serious discussions about whether 3I/Atlas might actually represent evidence of intelligent navigation instead of just natural gravitational influences during its passage through our solar system.
The hidden approach strategy.
Perhaps the most disturbing aspect of 3I/Atlas's trajectory is its perihelion timing, which, honestly, creates a strategic blind spot for Earth-based observations during the most critical phases of its passage through the solar system. The object's closest approach to the Sun happens when Earth is positioned on the opposite side of our star, which severely limits our ability to observe it during the period when thermal effects should be most pronounced. Statistical analysis shows that only about 7% of random interstellar trajectories would produce such observationally challenging timing, suggesting either an extraordinary coincidence or maybe deliberate planning to minimize detection and study opportunities. Dr. Paul Chodas from NASA's Center for Near-Earth Object Studies points out that this timing pattern would actually be ideal for a reconnaissance mission trying to study our solar system while avoiding detailed scrutiny from Earth-based instruments. This positioning allows 3I/Atlas to conduct close-range observations of multiple planets, including Earth. while staying mostly hidden behind the sun during its most active phases. What's even more concerning is that evidence suggests the object's brightness variations follow patterns that hint at controlled orientation changes, potentially optimizing its observational capabilities while minimizing its visibility signature. Critics, of course, argue that this interpretation leans too heavily on circumstantial evidence and ignores natural explanations. But, the accumulating patterns are becoming pretty difficult to dismiss as just pure coincidence.
Scientific opposition and evidence.
So, the mainstream astronomical community, they've mounted some pretty strong opposition to these artificial origin theories. Their main point is that, well, extraordinary claims require extraordinary evidence, and honestly, that kind of evidence just hasn't been provided for 3I/Atlas. The Space Science Institute, for example, emphasizes that while unusual orbital characteristics and timing coincidences are definitely intriguing, they don't really constitute proof of intelligent design or extraterrestrial technology. Leading cometary scientists also point out that interstellar objects naturally show properties that are, pretty different from solar system natives, and that's mostly because of their exotic formation environments and exposure to harsh interstellar conditions over millions of years. Now, when it comes to size estimates for 3I/Atlas, things get even trickier. The numbers are, well, highly uncertain, ranging anywhere from 5 to 20 kilometers, and that depends a lot on assumptions about surface reflectivity and composition, so making a definitive characterization is, honestly, extremely difficult. Dr. Quanzi Ye from the University of Maryland, for instance, argues that the object's minimal outgassing could actually result from surface processing during its interstellar journey, rather than from any kind of artificial suppression of natural comet activity. Spectroscopic observations have detected conventional water ice and carbon-based compounds, which are totally consistent with natural comet composition. Still, proponents of artificial origin theories point out that camouflaging technology could, in theory, easily incorporate such materials. All in all, the scientific debate here really reflects some fundamental philosophical differences about the burden of proof and, what the appropriate response should be when we come across anomalous observations that challenge our established paradigms.
Ancient origins and anomalous behavior.
Age determination studies suggest that 3I/Atlas may be over 7 billion years old, making it significantly older than our solar system and, well, raising some big questions about its formation environment and subsequent history. This extreme age implies the object formed during the early phases of galactic evolution, when stellar metallicity and planetary formation processes were dramatically different from what we see today. Despite its comet-like classification, 3I/Atlas displays virtually no visible tail or coma development, even during close solar approaches, which really contradicts some fundamental principles of cometary physics and sublimation processes. Dr. Colin Snodgrass points out that the object's thermal infrared signature just doesn't match standard models for water-ice sublimation, suggesting either an unusual composition or maybe even artificial thermal regulation. Structural analysis, meanwhile, indicates internal density variations that seem inconsistent with natural accretion processes, potentially implying deliberate construction or modification over geological timescales. The water-ice spectrum also shows anomalous absorption lines that don't perfectly match laboratory standards, hinting at either exotic crystalline structures or contamination with unknown materials. And if that wasn't enough, there are periodic brightness fluctuations that occur independently of the object's rotation, which suggests internal activity or controlled surface changes, rather than just simple light reflection from a tumbling asteroid. Taken together, these ancient origins and anomalous behavior patterns create a compelling case for detailed investigation instead of premature dismissal. Since 3I/Atlas may represent our first opportunity to study technology or materials from civilizations that evolved billions of years before Earth even formed.
The stealth hypothesis.
The concept of deliberate concealment adds, honestly, a chilling dimension to the 3I/Atlas analysis, suggesting the object may be operating under dark forest theory principles, where advanced civilizations actively avoid detection by potentially hostile neighbors. This hypothesis proposes that 3I/Atlas represents sophisticated camouflage technology designed to appear as a natural comet while actually conducting systematic reconnaissance of our solar system and Earth's technological capabilities. Dr. Seth Shostak from the SETI Institute acknowledges that, while this idea is speculative, stealth hypothesis explanations account for otherwise inexplicable observational patterns, better than conventional astronomical models. The perfect timing of its approach, strategic positioning during key observation windows, and minimal electromagnetic signature could all indicate advanced concealment protocols developed by civilizations with millions of years of technological evolution. If confirmed, these stealth capabilities would suggest that 3Y Atlas represents technology far beyond anything humans currently understand, potentially indicating that extraterrestrial surveillance of Earth has been ongoing for extended periods without our detection. The implications here extend well beyond simple scientific curiosity to fundamental questions about human security and our readiness for contact with advanced civilizations that may be studying us from the shadows. Now, critics argue that stealth hypothesis thinking promotes paranoid speculation rather than rigorous scientific analysis, but proponents note that dismissing possibilities just because they're unsettling is more emotional than logical reasoning. The debate continues to influence both scientific methodology and public policy discussions about how humanity should prepare for potential contact with extraterrestrial intelligence operating within our cosmic neighborhood. Lessons from Oumuamua. The scientific community's response to 3Y Atlas has been, in many ways, heavily influenced by the controversial handling of Oumuamua back in 2017, when humanity's first confirmed interstellar visitor was dismissed as merely unusual instead of potentially extraordinary. Dr. Avi Loeb argues that the astronomical establishment's rejection of artificial origin possibilities for Oumuamua represents a missed opportunity that really shouldn't be repeated with 3I Atlas. The earlier visitor's anomalous acceleration, extreme elongation and lack of outgassing were explained away through increasingly complex natural theories, rather than seriously investigating simpler artificial explanations. Today, our detection capabilities and analytical techniques are way more advanced than during Oumuamua's brief passage, providing unprecedented opportunities for detailed characterization of 3I Atlas before it disappears into interstellar space. The James Webb Space Telescope, advanced spectrometry, and artificial intelligence analysis systems now offer tools that were unavailable or underdeveloped during our first interstellar visitor encounter. The lesson from Oumuamua is clear. It's important to investigate all possibilities, including extraordinary ones, rather than defaulting to conventional explanations that may not adequately address observed anomalies. 3I Atlas represents potentially humanity's second and possibly final chance to properly study an interstellar visitor during this generation, making thorough investigation crucial, no matter the initial skepticism. Scientists worldwide are coordinating unprecedented observational campaigns to ensure that this opportunity isn't wasted through premature conclusions or insufficient data collection. The stakes honestly couldn't be higher, since 3I Atlas may be our last chance for decades to determine whether we're alone in the universe or sharing it with advanced civilizations. The mystery of 3I Atlas continues to deepen with each new observation, challenging our understanding of what's possible in the cosmos. Whether it's an ancient comet with unusual properties or, something far more extraordinary remains hotly debated among scientists worldwide. What do you think about these strange findings? Could we be witnessing our first confirmed encounter with extraterrestrial technology? Share your thoughts in the comments below, and don't forget to subscribe to Sci and Y, and hit the notification bell for more mind-bending space mysteries. Keep questioning the universe. A massive and mysterious visitor, 3I Atlas, is currently making its way through our solar system, electrifying scientists worldwide and, honestly, challenging our understanding of cosmic visitors. Data collected by NASA has revealed astonishing details that just defy conventional scientific understanding and spark some pretty intense debates about its origin. Some experts now suggest that this interstellar object may be more than just an asteroid or comet. It might actually be an alien spacecraft. Today we delve into the groundbreaking discoveries, the enigmatic nature of 3I Atlas, and the profound implications for humanity's understanding of the cosmos. The breaking discovery. In June 2025, astronomers detected a colossal object moving rapidly through our solar system, immediately distinguishing it from typical asteroids or comets. This became the breaking discovery known as 3Y Atlas, representing humanity's third confirmed interstellar visitor. With an estimated diameter between 10 to 20 kilometers, it absolutely dwarfs previous interstellar visitors like the enigmatic Oumuamua, which measured only about 400 meters in length. Early analyses revealed unusual properties that immediately caught scientists' attention, including its incredible speed exceeding typical interstellar velocities, an atypical retrograde orbit that just kind of defies conventional expectations, and a surprisingly metallic surface composition that really challenges our understanding of interstellar objects. These characteristics collectively raised significant eyebrows throughout the international scientific community and sparked intense debate about its true nature. The object's detection has ignited a global race among observatories and research institutions to understand its fundamental nature and ultimate origin. As preliminary data suggests, it may harbor secrets and technologies far beyond the scope of established planetary science and our current understanding of natural cosmic phenomena. The discovery story. The discovery of 3Y Atlas was entirely serendipitous, first spotted by the Asteroid Terrestrial Impact Last Alert System or ATLAS network of telescopes located in Hawaii. Within mere hours of the initial detection, telescopes worldwide rapidly pivoted their instruments to observe this enigmatic cosmic intruder racing through our solar system. The International Discovery Team, led by Dr. Larry Deneau from the University of Hawaii, quickly combined ground-based optical data with sophisticated space-based infrared observations to conduct comprehensive analysis of the object's properties and trajectory. Initial identification relied heavily on advanced artificial intelligence algorithms that efficiently sifted through vast streams of astronomical data to isolate the object's unique hyperbolic trajectory and unusual characteristics. Unprecedented coordination among international observatories, including facilities in Chile, Australia, and Europe, ensured rapid data accumulation and cross-verification, enabling researchers to characterize the object's size, shape, velocity, and preliminary composition within just weeks of discovery. This collaborative effort demonstrated the power of modern astronomical networks in detecting and analyzing rare cosmic phenomena that previous generations of astronomers could never have imagined observing with such precision and detail. A stranger in our midst. 3I Atlas is no ordinary cosmic interloper. It fundamentally challenges every scientific expectation and theoretical model for interstellar visitors. Moving in a distinctive hyperbolic retrograde orbit at approximately 58 kilometers per second, the object appears to possess an unusually smooth, highly reflective metallic surface, with anomalous reflectivity properties that really puzzle researchers. NASA's James Webb Space Telescope has detected crucial aspects of its surface composition that strongly suggest advanced material properties and engineering techniques, possibly indicating sophisticated artificial construction rather than natural formation processes. The object's behavior and characteristics have created deep divisions within the scientific community. While some researchers desperately advocate for conventional natural explanations involving exotic stellar processes, others increasingly speculate about the possibility of advanced extraterrestrial engineering and technology. The metallic composition shows isotopic ratios that don't match typical solar system materials, suggesting formation under entirely different stellar conditions or through artificial processes unknown to human science. These unprecedented properties make 3I Atlas a focal point for heated debates about the possibility of alien technology visiting our solar system, forcing scientists to reconsider fundamental assumptions about the nature of interstellar objects. The predecessors. Before 3I Atlas arrived to revolutionize our understanding, humanity had confirmed only two other interstellar visitors: the mysterious Oumuamua in 2017 and the more conventional comet Borisov in 2019. Both predecessors were relatively small objects that exhibited behaviors generally consistent with natural cosmic bodies, though Oumuamua's unusual characteristics sparked, some initial controversies. Oumuamua's distinctly elongated cigar-like shape and puzzling non-gravitational acceleration really intrigued scientists worldwide, but ultimately left many fundamental questions completely unanswered about its true nature and origin. Comet Borisov's behavior aligned much more closely with scientific expectations, displaying typical cometary activity, including a visible coma and a distinctive tail as it approached the Sun. Together, these earlier discoveries paved the way for advanced detection techniques and heightened international interest in systematically studying interstellar objects, while also developing the theoretical frameworks necessary for understanding such exotic visitors. The progression from Oumuamua's mysteries through Borisov's conventional behavior to 3I Atlas's unprecedented characteristics illustrates the remarkable diversity of objects traveling through interstellar space, setting the stage for this latest visitor's truly extraordinary and potentially paradigm-shifting arrival in our cosmic neighborhood. The Cosmic Journey. Traveling at breathtaking speeds through the vast emptiness of interstellar space, 3I Atlas entered our solar system after completing an epic odyssey spanning potentially billions of years across the galaxy. Its precisely calculated trajectory brings it within optimal observational range of Earth for only a critically brief period, creating honestly, intense pressure on astronomers to maximize data collection opportunities. Scientists and engineers at NASA's Jet Propulsion Laboratory continuously track its complex course through gravitational fields to better understand the fundamental forces governing such ultra-high-velocity objects during their passage through planetary systems. The object's gravitational interactions with our Sun and major planets provide unique and invaluable data for studying cosmic dynamics and the behavior of matter under extreme conditions rarely observable in nature. Analysis of its ancient journey provides crucial clues about the evolutionary history of distant planetary systems, stellar formation processes, and the mechanisms by which objects can achieve such extraordinary velocities. The object's trajectory suggests it may have originated from a stellar system located hundreds or even thousands of light-years away, having traveled through multiple galactic environments and possibly encountered other star systems during its epic voyage. Its current path will eventually carry it back into the depths of interstellar space, making this encounter a once-in-a-generation opportunity for scientific discovery. A scientific goldmine. 3I Atlas represents an unprecedented scientific goldmine for researchers worldwide, offering unique opportunities to study interstellar materials and processes never before accessible to human science. Its remarkable size and completely unusual physical properties allow for detailed, multi-wavelength observations and sophisticated analytical techniques that would be impossible with smaller objects. Comprehensive observations from telescopes worldwide, including advanced spectroscopy and polarimetry measurements, are gradually revealing complex surface chemistry and internal structure that challenge existing theories about cosmic object formation. International teams of researchers hope to unlock groundbreaking insights into the formation mechanisms of interstellar objects, the fundamental nature of extraterrestrial materials, and possibly revolutionary technological applications if artificial influences are definitively confirmed through ongoing analysis. Collaborative efforts between major space agencies, universities, and research institutions worldwide are working to maximize data collection within the severely limited observational window available before the object moves beyond detection range. The object's unique properties are providing new insights into exotic matter states, advanced materials, science, and possibly propulsion technologies that could revolutionize human space exploration capabilities. Every day of observation yields new discoveries that are frankly reshaping our understanding of what's possible in the cosmos, making 3I Atlas one of the most scientifically valuable objects ever studied by human civilization.
Unanswered questions.
Despite extensive research efforts by leading scientists worldwide, numerous fundamental questions about 3I/Atlas remain completely unanswered, creating scientific mysteries that challenge our current understanding of physics and cosmic phenomena. The object's internal structure, true point of origin, and ultimate purpose continue to be subjects of intense study and honestly increasingly bold speculation among researchers. Highly unusual acceleration patterns and anomalous reflectivity characteristics significantly complicate traditional classification systems and force scientists to develop entirely new theoretical frameworks. The persistent possibility of artificial manipulation or intelligent guidance adds multiple layers of complexity to an already puzzling scientific enigma that, well, just defies conventional explanation. Critical data gaps resulting from limited observation time, government-imposed information restrictions, and the object's extreme distance from Earth continue to hinder efforts to reach definitive conclusions about its nature. The object's behavior patterns suggest responses to external stimuli, that could indicate either advanced natural processes or sophisticated artificial intelligence systems operating according to unknown principles. Scientists worldwide emphasize the critical importance of maintaining open minds as theories evolve and new findings emerge, stressing the need for careful balance between healthy scientific skepticism and genuine wonder at phenomena that may represent completely new categories of cosmic objects never before encountered by human civilization. The alien question. So, the controversial alien hypothesis suggests that 3I/Atlas might not actually be a natural cosmic object at all, but rather, an advanced extraterrestrial spacecraft, probe, or, some kind of technological artifact from a distant civilization. Prominent supporters of this theory, including Harvard astrophysicist Dr. Avi Loeb, argue that certain observed behaviors and material properties really do provide compelling evidence of intelligent design and sophisticated engineering. Honestly, way beyond anything humans are capable of right now. This revolutionary viewpoint fundamentally challenges scientific orthodoxy and the traditional approaches we take to classifying cosmic objects, but it has actually gained significant traction, especially with all the growing evidence of unexplained aerial phenomena and possible technological signatures. The hypothesis points to the object's apparent ability to alter its trajectory, its unusual metallic composition, and its anomalous reflectivity as potential signs of artificial construction and maybe even active guidance systems. If this controversial theory turns out to be accurate, the implications for humanity would be absolutely profound, potentially signaling our very first direct contact with extraterrestrial intelligence, albeit through an uncrewed interstellar emissary or reconnaissance probe. The alien hypothesis has sparked some pretty intense debates within the scientific community about what standards of evidence are really required for such extraordinary claims, and what the potential consequences might be if we actually confirm extraterrestrial technology operating within our solar system. This paradigm-shifting possibility really forces humanity to confront some fundamental questions about our place in the universe and whether or not we're actually ready for contact with advanced alien civilizations. Observing the visitor. Global efforts to observe and study 3I/Atlas have honestly become an outstanding example of international scientific collaboration, with observatories using radio, optical, and infrared technologies all working together to capture every possible bit of fleeting data. Space-based observation platforms, including the James Webb Space Telescope and the Hubble Space Telescope, are working in perfect coordination with ground-based observatory arrays, providing comprehensive coverage across multiple electromagnetic spectra. These intensive observations specifically aim to figure out the object's detailed composition, look for any trajectory anomalies that might suggest propulsion, and of course, detect any emissions or technological artifacts that could point to advanced engineering. The coordinated global effort actually involves dozens of major observatories across 6 continents, representing the largest international astronomical collaboration in modern history. Advanced artificial intelligence systems are processing vast amounts of incoming data in real time, searching for patterns and anomalies that might reveal the object's true nature and purpose. Radio telescope arrays are constantly monitoring for any potential signals or communications from the object, while optical instruments track even the tiniest changes in brightness and orientation. This observation campaign really does represent humanity's most sophisticated attempt yet to study a potentially artificial object from beyond our solar system, using every available technological resource to unlock the secrets of this mysterious visitor. Dawn of a new era. The detection and comprehensive study of 3I/Atlas truly herald the dawn of a revolutionary new era in astronomy, planetary defense, and honestly, humanity's understanding of our place within a potentially populated galaxy. With future astronomical surveys like the Vera C. Rubin Observatory expecting to discover dozens of additional interstellar objects every year, humanity is, well, standing right on the cusp of unprecedented cosmic discovery and even potential contact with alien civilizations. These mysterious visitors fundamentally challenge our existing understanding of natural celestial mechanics, and really force us to reconsider our planet's position within a galaxy that might actually be teeming with advanced life, sophisticated intelligence, and highly developed technological civilizations. The implications go way beyond just scientific curiosity. They could affect human philosophy, religion, technology development, and even our species' long-term survival strategies in what appears to be a pretty active galactic environment. Advanced detection and analysis systems currently under development will provide early warning and detailed characterization of future interstellar visitors, potentially including genuine alien spacecraft or communication probes. The study of 3I/Atlas has already revolutionized our approach to cosmic object analysis and set new protocols for investigating potentially artificial phenomena from deep space. As our observational capabilities keep expanding and improving, we might soon discover that interstellar visitation is far more common than we ever imagined, fundamentally transforming humanity's cosmic perspective and our understanding of galactic civilization and intelligence. The mysterious visitor 3I/Atlas continues to captivate scientists and space enthusiasts all around the world, revealing cosmic secrets that could fundamentally redefine our place in the universe. As our technology advances, so does our ability to detect and understand these enigmatic interstellar emissaries. So what do you believe 3I/Atlas truly represents? Share your thoughts in the comments below, subscribe to Sci and Y for more cutting-edge cosmic insights, and join us as we explore the ultimate mysteries of space. Until next time, keep watching the skies.